Okay, we're doing some work out of the textbook and we're trying to visualize the data that we're collected. So there's a lot of questions here asking you to make a dot plot or a bar graph of the data that you presented with. So I've done that here, and I'm going to do it on the light board in a moment here. And it's one of those things. It's a speed versus accuracy type thing. And what I prefer at this stage is some rough sketches. We're doing work out of the textbook. If I was going to publish this data, I would make it look really nice and make it look very professional, but I'm not doing that. I'm just practicing and laying things out. So I'm thinking about this question here. I've got collected some data, asked some people, random people off the street, how many times they visited the doctor this year. And some people might have said, no, I didn't go to the doctor at all, and I've had a good year. And that's real. These are real values, and that's expected. Some people, when you ask a cross-section of the population, some people might have not visited the doctor, or in the sample that I collected, I might have had one person here say, yeah, I went once this year. Most people you'd expect possibly go to the doctor twice or 3 times a year for checkups, or they've got an illness or something. So you kind of get a sense of that plays out in real life. And so for each person I've asked, there's a data point. So you can count up those data points and you can say, well, you know, how many people are involved in this survey? Okay. Now, we could have some outliers here, and it's really important that we do, and this is why I've chose this example here. You can see there, I've asked this in this survey here, I've asked someone and they've said, oh, I've had a terrible year, I've had an ongoing problem, and I've been to the doctor 10 times this year. We understand that. That's reality for this person. Okay, but this data point here, we would consider this to be an outlier. We would consider that having some effect on the rest of this data here. But the thing with outliers is that we've got rules about them, whether you include them or you discount them. This is not a mistake that's been made with the measurement. This is, in this example, it's why I use it. This is a real person. They've been to the doctor 10 times. So we can't discard that data point. And with outliers, we're often really wanting to ignore it or pretend it didn't happen. So because it messes up everything else what's happening here. But it's above what we're doing here, but I just want you to understand that these data points, either they can exist because they're real things, or they could be a error. Okay, it could be the case if I had made a mistake, instead of writing 1, I might have looked at my notepad and accidentally wrote a 10. And if that was the case, then I could discard it. But if it was actually a real event, I can't. So we have to be really careful about making those judgments. And statistics is about making these kind of decisions and seeing how it all plays out. So the other thing I want you to notice, this is my really rough sketch. I've included the axis down here and labelled it number of visits to the doctor. Or maybe I could have put the other bit here. And the other thing I tried to do is make my dots, for example, all sort of in the same position. Because the other thing I can do is come along here and quickly turn this into a bar graph. It's not that big of a leap to imagine turning the data into a bar graph like that. Okay? And it's not that big of a leap really to imagine turning this into a line. I would probably make that look like something like that. Because down in here, maybe it's just because I haven't asked enough people here. I'd expect if I had a larger sample size, this would sort of look like a curve going over the top of here. And of course, a nice big long tail out the other side. So that's all part of, I guess, the things that you need to consider. Now, your examples in the textbook are pretty sort of, what are they, curated sets of data. So they're there to demonstrate a certain point. I'm kind of more used to working with real sets of data and having to make a lot of these decisions. So I'll get on the light board and show you a few other little things to consider. Okay, so I spent a bit of time talking about outliers, and I've just put in here they're a little bit suspect, and we've got to be really careful about them. There's actual rules around what we call possible outliers, and you don't need to know that right now. You just need to know that these points, what we call outliers, are often sitting outside the bulk of the data, and we kind of scratch our head wondering whether they are real. And maybe, as I pointed out in the last example, they are real. Okay, in which case we just leave them in there. Or there may be some kind of error, and that error may be in the measurement or the recording of the data. Okay, so let's have a look here. There's an example of a dot plot here, and that's the bulk of the work. Here we've got a dot plot, and we've got a dot to represent each point. So if you did a survey and you asked people how many times they've been overseas, you would kind of expect a lot of answers around either none, so 0, 1, 2 or 3. Maybe we've been on a couple of holidays overseas somewhere, but it could be, this could be a real response from someone that you selected at random, and they might do a lot of traveling for business, for example, and they've been their response is, I've been overseas 20 times. Okay, so that's real, and you cannot discard that data point. Okay, so let's think about what these plots are representing. I could write this as a list, and I really don't want to do it, but for example, there's 3 zeros there and there's 5 ones, and this all gets a bit clunky, and so at some point we're better off to represent it as a type of graph. Okay, and like I pointed out to you, it's quite easy to turn these things into bar or column graphs. Okay, and what I like to do often is, if there's 3 data points there and 5 data points there and 4 here and 3 here, I often write those things on the top, because that helps me to take the data, and I know I'm just doing a quick little sketch here and nothing's perfect, so writing the numbers just above the column is really useful. Okay, so you can go along and do the other things that you we'll talking about in other videos. So how many data points have we got here? We've got 8, 12, 15, 16 data points here. So the n, or the number of data points we've got in this graph, is 16. We can find the mode, and that is going to be the most commonly occurring response, which is 1 trip overseas for 5. Okay, you can do the range, which we say 20, subtract 0, so that's going to be equal to 20. We can find the median value, And the median, what we do there is we count the points in. So 16, we've got to get to 8. 3, here's 8. So the median is in between these two columns here, which we would write down as 1.5 trips overseas. And this is just a summary statistic. Okay, you can't actually have 1.5 trips overseas. I don't understand how that works. And you could go and calculate the mean as well, but I think it will be somewhere in a similar sort of thing. It'll be somewhere between 1 and 2 trips overseas, just looking and visualizing and seeing where the middle of the data is from those types of graphs is often a good way to get a ballpark figure about where the middle is. I'm just going to pause the video. I'm going to create a bit of space here because I've got one more question I want to answer with you, and I'll show you a few different ways to do this. Here's an interesting question, and we're talking about drawing graphs, and we're talking about drawing dot plots and column graphs, and it might seem odd. I'm going to show you a different way to represent this data because it's a really nice example, I think, of how to quickly sketch out a graph and get the information that you need from a table like this and find a visual way to represent it. So we've got a survey of the number of boys and girls born in a hospital somewhere, and the data goes from 2010 to 2015 years. 2015, so we've got 5 years worth of data here. And if you're not familiar with this, these symbols here are male and female symbols used in science, and I'm going to use them a little bit because I'm looking for a quick way to sketch the data here and get a sense of what's happening here. And like, if you're interested in your biology, then we should have like a 50% boys and 50% girls on average. So you know, that's the way, in a large population, that's what we should be looking at. So it should be a 50-50 split between boys and girls here. And looking at the data, that doesn't seem to be the case in this. So how would I sketch this out? And what I would do, and I might use a bit of room up the top here, I'm going to draw a set of axes, and I can see most of the values here, you know, are somewhere between 30, 40 and 50. So I'm just going to draw some lines across here and at these various points, and maybe I need to put my label my axis year. So this is number born, might be a good way to do that. 2010, 2011, 12, 13, 14 and 15 would be my quick little sketch. Just going to change the color of my pen, and let's put the boys in here because what would I do? I'd use my symbols here. That's 40. Just going to write underneath it, and beside it, let's do all the boys. Okay, so 40. I used the wrong symbol too, didn't I? Wow. Boys, 2011, 42. I'm just going to write the number underneath it. 2012 we're at 58, so we're somewhere up here, and 58. And then 2013 we're at 45, so somewhere in the middle here. There's my boys, and what did I say, 45. Then in 2014 it was 30, so let's do this and write the number underneath it. And then for 2015 we're at 42. 2. So change the colour, put the girls in, and we're at 50 here, 40 here, so we're roughly the same. 53, so beside it, 53 might be somewhere there. 53, put my number in. 40, 41 there, and 26 here, and finally 35 somewhere here. 35. So that's what I would do in response to this question, and it's neither a column graph or a bar graph, and I've just used the symbols and I've put in the numbers, and there's my rough sketch to give you some sort of sense of what's happening with this data. But here's the next bit. This is why I wanted to show you this question, because they ask you whether there was more boys or girls born over that 5-year period, and this is our key bit of knowledge here. So what this is the sex ratios. There should be 50% boys and 50% girls. So here's a nice little move that I've got here. I'm putting a dotted line in here because that's going to be even, if you like. What I'm going to call that is even. And above the line, I'm going to put boys. Okay? And I'm going to put girls below the line. And so when I look at the first column here, I see that there's 10 more girls. So I'm just going to put an arrow there and put plus 10. Then what happens on the next one, I've got plus 2 boys. Plus 2. The next one, I'm at plus 5 for the boys. And let's have a look here. Plus 4. And plus another 4. And here, finally, what happened? I've got 7 more boys. Okay, so to answer this question, right, and what I want to show you here is setting up this graph gives me the differences each year. And if I can do this now, look, I could have went through the table and added all those numbers up. It got really crunchy. And watch this. If I do this, that cancels out the 10 girls with the 10 boys. And what am I left with? To help me answer this question, how many more boys are born? Well, that is 12 more boys. We've got plus 5, plus another 7, and we're at 12 more boys are born over that 5-year period. And to me, that is the value of drawing graphs and thinking really carefully and critically about what you're doing and what you're sketching and the story that you're telling. Okay, so I hope you found that useful, and more than that, I hope that it sort of takes away that crunchy, grindy kind of work for you and makes it a bit more A, enjoyable, and B, helps you move through the questions a bit easier. All right, thank you.